We have our second example, a three-hinged truss. The height is 8 meters and the span is 16 meters, 4 by 4, which means that each panel, FG, GC, CH, and HI, 4 panels, each has a 4-meter length, and the total is 16 meters. From the dimensions, we can conclude that ADC makes an angle 45 degrees with the horizontal. Three-hinged truss has 3 hinges A, B, and C. Of course, all other joints are complete hinges in the truss, but A, B, and C are special joints. A and B are external hinge supports. C is a unique internal hinge, as the cut at C completely separates the truss into 2 different parts. Now we compute our reactions. We have 2 reactions, X and Y at A, and 2 reactions at B. Sigma moments at A cancels XA, YA, and XB as the 3 forces pass through A, the 3 unknowns. Also, the external 10 tons at F doesn't have an arm about A or passes through A, and therefore does not appear in our equation. We are left with 10 tons at C multiplied by the arm 8, and note that the 10 tons rotates clockwise about A. So any other force that makes a moment rotating in the same sense clockwise will be considered positive, and any other force rotating in an opposite sense counterclockwise about A will be considered negative. Now we have 10 tons multiplied by 8 and 10 tons multiplied by 16, and YB rotating in an opposite sense. The arm from YB to A is 16 tons equals 0. Please note that the arm of the force is the length between the point about which the moment is taken and perpendicular to the force. This gives YB equals 15 tons and is plotted on our diagram. Sigma forces in the Y direction equals 0. We consider all forces in the Y direction, YA and YB heading upwards and having the same sign. The 3 10 tons heading downwards and have an opposite sign, noted here as minus 10 by 3. This gives YA equals 15 tons as YB is previously computed, and the force is plotted on our diagram. Of course, we could have considered symmetry of the truss and simply conclude that YA equals YB equals 15 tons. To compute the horizontal reaction X, B, we consider moments about C and we take only the right part. We consider only the right part in the equation. So we have 10 tons at I multiplied by the arm 8 until we reach C, minus 15 tons YB multiplied by the arm 8 until we reach C, plus XB multiplied by the arm, the vertical length, which is perpendicular to XB, 8 meters. This gives XB equals 5 tons and is plotted on the diagram. Sigma forces in the X direction equals 0, gives that XA equals 5 tons and is plotted on our diagram. Now we are ready to compute the internal forces. We take section S1, as shown on the diagram. The section divides our truss into a left part and a right part. We can consider any part we are convenient with. In our example, we will analyze the left part. Of course, the internal forces that show up are the forces in the members through which the section passes, but any other member doesn't show its internal force by the cut of S1. We extract the left part to make our computations. First, FGC is analyzed into the horizontal component and the vertical component. Sigma forces in the y direction equals 0. We consider all forces in the y direction. We have the YA, the FGC sine 45, and the 10 tons, and we respect the signs. This gives FGC equals minus 7.07 compression and is plotted on our diagram here. We consider the forces in the x direction for the left part of the section. We have 5 tons XA, the horizontal component of FDC and FGC. Note that FGC is previously computed and we substitute by its value and its sign. This gives FGC equals 0 and is plotted on our diagram. Now we consider another section, S2, that cuts the truss into 2 separate parts. We can consider the left part or the right part. We will consider the left part. Please note that the internal forces that show up by the virtue of the section S2 are only the forces in the members having the cut of S2, FG, FD, and F and AD. We consider the section we extracted outside to have our computations. FDA is analyzed into a horizontal and a vertical component for the convenience of computations. Considering sigma moments about D equals 0, the forces of FD and DA do not appear in the equation as they pass through D. The forces are 15 tons and 10 tons acting in an opposite direction, multiplied by the arm 4 meters. The 15 tons rotates in a clockwise with a positive direction, considered to be positive, and the 10 tons rotates in an opposite direction about D, and therefore they are taken just in one shot as they have the same arm 4. XA equals 5 tons and the arm of it is 4 meters until we reach D. So minus 5 by 4 plus the force in FG multiplied by the arm 4 meters until we reach D. This gives the force in FG equals 0 and is plotted on our diagram here. Sigma moments about F equals 0. Of course, the forces in FD, FG are not computed as they pass through F, and we are left with the only internal force in dA to be the unknown. YA doesn't have an arm about F and is not considered in the equation. XA will be considered, and our equation is FDA cosine 45 multiplied by the arm AF equal to 8 meters, XA 5 tons rotating in the same sense about F as the force dA, and multiplied by the arm 8 meters. This gives FDA equals minus 7.07 tons, and therefore is a compression force and is plotted on our diagram here. Now we consider the forces in the y direction. Sigma forces in the y direction equals 0. Now we need to analyze the force in FD into the two components, one horizontal and the other vertical. Considering the forces in the y direction, we have the 15 tons and 10 tons external forces, internal forces, FDA sine 45, and the component of the force in FD in the y direction. So we have this equation, which gives the force in FD equals 0 and is plotted on our diagram here. To proceed with the internal forces, take joint F, and here we note that all internal forces are considered to be tension forces, as explained in previous lectures. Considering any member, say FG, the internal forces have arrows tending towards each other, which means that the internal force is a tension force, and the details are previously explained. We consider joint F. We extracted outside to have our analysis. FG makes an angle 45 with the horizontal, and therefore it has the components cosine 45 in the x direction and the force multiplied by sine 45 in the y direction. Consider the equation sigma forces in the y direction equals 0. We have FD previously computed and equals to 0, and we are kept with the force in FA, the only unknown, to be minus 10 tons, and compression, and plotted on our diagram here. Taking joint G, we extracted outside with all the internal forces connected to it. In other words, all the members connected to it, GF, GD, and GC. From the geometry, it has no external forces applied on it. Considering the forces in the y direction, we have the force in GD equals 0, as there are no other forces in the y direction. We plotted on our diagram. This concludes with our truss. Of course, we know that the right part is identical to the left part, and therefore it was sufficient to compute one part.